This spring we built a chicken coop to house our new flock of birds. We decided that for sustainability we really wanted to have chickens around our homestead. So in the fall, to keep them laying, they do have to have an additional light source. And since we're in the solar industry, we decided that we would go with a solar chicken coop lighting setup. So up on the roof we have our 175-watt panel, and we're going to go ahead and show you the whole process of putting the solar system into the chicken coop so that they can have light. Okay, so today what we're going to work on is some lighting for our chicken coop. We've bought these 12-volt LED string lights, and they are 48 feet long, and our chicken coop is 24 feet long. But with the space across the back, we need to extend these by about 8 feet so that they will go down both sides of the chicken coop.
So basically what we're going to do here is try to find the middle of this and cut it in half. I find rather than measuring, generally speaking, the easy way to find the middle is to do something like that. So we're going to line up our sockets. I can get everything untangled here for you. So I want to line up our first sockets, so we have an even number of sockets on each side of the chicken coop. 2, 3, 4, 5, 6 on each side. So then we're going to basically cut it right in the middle of that right there. Strip this insulation back, and this is only 12 volts, so this is why we're doing it the way we're doing it. If it was 120 volts, we'd be doing it in junction boxes, doing it more weather tight, etc. And it's under the eaves of the chicken coop, so it's not really going to matter. I'm just going to cut that off. I'm going to go ahead. I like to cut my wires a different length, and that way the splices are offset from each other. Twist the wires up before we put them in the butt splice that we're going to use. Basically use the yellow location on the yellow butt splice. Same on the white. And then I've already stripped one into this back, so I'm going to show you how I did the other end. It's basically the same as the other cable. This is just a what they call an SO cable. It's outdoor rated flexible. It's kind of like extension cord material. Can be bought at any hardware store generally. And you notice it has an extra wire in it. It has a ground. The lights don't have a ground, so we're going to go ahead and cut that off. And then similar to our other one, we're going to offset these wires the opposite way. And you'll see why that becomes more important later. inside the black. Same thing with the crimper. And the white inside the white. And you'll notice it's not quite lined up. I'm going to go ahead and cut off a little bit more of that. The reason I offset them is you see they're just a little off from each other, which makes taping this up a little easier. You could use heat shrink here, and if this was exposed to the weather, I would definitely use a heat shrink. You could also solder the wires, but again, it's 12 volts, it's a chicken coop. So we're not going to get too worried about that. There. And then we're going to do the other way, the other end the same way. I'm not going to bother to video that. It happens just exactly like that. So here in just a second, we're going to go out and hang these up on the chicken coop. Alright, we're going to finish taping up this adapter. So what we are going on here is this 12 volt light kit you get off Amazon. It comes with a 120 volt adapter or a pigtail to hook up your 12 volts. So what I did is I extended the wire so we can reach our breaker box that we're going to have, which we'll show you in just a second. So that's all ready to go to the chicken coop when we're ready. But what we're going to do, now that we've spliced this wire together to go around the end of the chicken coop, we're actually going to use that 120 volt adapter to our advantage. We're going to put a couple bulbs in on either side of this splice right here. And we're going to just make sure that our splice is good before we go ahead and hang this all up on the chicken coop and find out that we did something wrong. Now we're just going to plug it in and see if both lights come on. And both lights come on. So that tells us the splice is good. So we're going to go ahead and undo that. We're going to take our bulbs back out so we don't break them. And this kit came with 12 volt LEDs actually. They're supposed to look like the old Edison bulbs. Alright, and we're going to go ahead and unhook the 120 volt adapter. And set that aside. And we're going to go ahead and put this roll of lights out of the way, and then we're going to explain what else we've got to mount. So when we get out to the chicken coop, we also have some interior lights. I did the research on the internet. I'm not sure how correct it is, but I got the LEDs with the proper Kelvin, around 2700 to 3000 Kelvin, which is what laying hens prefer, is what I'm told. There's actually a amount of lumens per cubic foot for your chicken coop as well. I calculated that I need a couple of these. These are about 7 watts a piece. We'll see how that works. But we've got our metal boxes to go inside the chicken coop, our fixtures for the lights, and again, these are 12 volt LEDs. We're using 120 volt light fixtures, but we're going to use low voltage wire. We have our Victron. It is a 15 amp 75 volt MPPT charge controller. What's cool about this charge controller, and the reason we got this one, is it has Bluetooth. So we can be setting out around our campfire, whatever, at the night, and we can turn on the ambient lights that we just got done hooking together with our cell phone. We can keep track of what's going on at the chicken coop with our cell phone, so that's kind of cool. We have all of our breakers, probably one of the most forgotten items in any of these type of systems, even though it's 12 volts. We don't want to burn our chicken coop down. So we have all the proper breakers. We have a Midnight Solar MNPV6 combiner box that we're going to use as a breaker box, and some strain release and other fittings that we're going to use. So we're at that point now where I guess we're going to go out and we're going to start mounting light fixtures and lights in boxes to the chicken coop. And then the next step after that is going to be doing all the wiring, actually making the connections. So I guess we'll head out to the chicken coop and see if we can't mount some stuff up.
And since those are Since this is a DC system, those are DC rated circuit breakers, which is important to use. You can't just use the standard off-the-shelf breakers from your Home Depot, because those are AC rated breakers and they will not actually break the DC power.
Yeah, and you could use fuses too. We chose breakers because we want to be able to turn things off and on. You could use just automotive fuses on 12 volts if you want to, but it's something that will break DC and protect your circuits was important. Okay, now we're bringing everything out to the coop here. We're going to go ahead and get set up to install the lights and everything else on the chicken coop. We'll be right back in just a second. Okay, we've gone ahead and figured out where our splice comes up here. So we have equal amount of lights on both sides of the chicken coop. Now what we're going to do is each light has a little hole over it. We're actually going to screw that up here onto our roof system. Something like that. And we're just going to move down through and do that for every light socket. I'm still undecided if we're going to need to actually staple the wire. We think that makes the most sense, going around them like that. I can run that later. It's actually just going to go right up through there like that. So we'll just do it now. Alright, we're going to go around to the other side and do the same thing. And I can neaten that wire up in a little bit. What I'm trying to do is keep these lights so they line up from side to side. Give or take a few inches. And then we're going to neaten up this wire on the end. See, we need a little bit of time. And we'll come back and spray paint this wire white so out of place. inside and get set up to mount the combiner box and charge controller. Alright, so now we're going to mount the charge controller and the breaker box inside. We're actually inside the outside run of the chicken coop under the roof, so it'll stay dry. So we're going to mount that. We're going to put a board up here to mount them on. Just little things that we're leaving space so no critters can build a house in behind it. Level. Being conscious not to use too long of the screw because I don't want it to come in on the other side with the chickens, of course. So now we're going to mount the little Victron. I'm going to mount it right here. Mount the breaker box. On the breaker box we got to actually open it up. I did not do that ahead of time. And one of the reasons we're mounting everything up high is we want to be able to cover this window over for winter. It gets pretty cold here in the winter and we want to keep the draft out of the chicken coop. And the chickens are very curious about what we're doing. There, now we're going to have to go inside and mount our inside lights, drill a hole out through to get the wire out through, and then it's down to just the electrical and adding the battery. So we'll be right back when we get inside and get ready to do that. Alright, so now we're inside. We're going to mount the two inside lights to help the chickens lay eggs. We went ahead and prepped them in the shop just to make it a little easier. So we're going to go ahead and put that one right up here. And then we're going to put this one over here. Take some of the twist out of that. We'll see if the battery holds up. What I'm doing now is just put some screws in so I can wire tie the wire across here to keep it from dangling too much for the chickens. They are very curious about what we're doing inside their house. think she's mad at me. You'll see in a minute, but I stored my light bulbs in her nesting box. I think she's confused because those aren't eggs. I'll go ahead and put one more wire tie on here. I have to drill a hole and run this wire up through. Alright, that should take care of it in here. We're going to go out and go ahead and keep working on some electrical. Alright, so we're back and we have the battery actually in. We did that off camera. So we've got our 12 volt, basically 100 amp hour, 86 amp hour actually, deep cycle lead acid battery. We're going to go ahead and put the cover on that. Yeah, the cable's a little stiff when it's cold out. Off the battery, that's where it's going to live. So then what we're going to do is we're going to hook up the PV module, which I showed you earlier. And what we did for that is we just bought a 50-foot MC4 extension cable and we cut it in half. So there's two different halves here. So we're going to go up and we're going to plug that on and we're going to staple it over to the box. So bear with me and that's what we will go do. One of the issues that we run into, we're not able to figure out from looking at the Victron manual real quick if it has common negatives or not. And what I mean by that is the charge controller takes a battery negative, PV negative, and a load negative for the lights. So not knowing, we're going to play it safe and we're going to treat it as though it cannot have common negatives. So we're going to have to run the PV negative directly to PV wires ran. We have to put a strain relief in through the PV wire. Which I have in one of my pockets. You'll notice we've already run our battery and our load lights into the box. Now we're going to run just one of the PV wires. But we don't know which one is positive and which one is negative. So we're going to check those. So we're going to put the voltmeter in DC volts, which is the flat line and the dashed line. And we're going to set it right there where the chickens can watch it. And we're going to get onto the PV wires. And right there, we don't have a negative sign in front of it. So that tells me I'm correct. I'm going to go ahead and reverse it and show you what I mean by that. So your voltmeter has one red lead and one black lead. And when you get it backwards, you see you'll have a negative emblem. So what that's telling me now is I'm measuring it backwards. So that is our negative, which we will double check once more just to be sure. A little hard to do with one hand, but one set of hands. But you'll notice I got the red lead on that lead, and the black lead is in my other hand on that lead, and I do not have my negative sign. So this is my positive. So this wants to go into the box. And the negative is going to go directly to the charge controller. Alright, so we're now going to work on hooking up all the wires to make everything work. We've gone ahead and landed our battery positive and our PV positive in here because those were live from the battery in the solar module. We put our breakers on the DIN rail. So now we're going to start wiring over to our charge controller. You'll notice that I've kind of tried to make it look somewhat neat. So we're going to use black for the load positive. I'm going to put that right there. Okay, now we're going to just put a couple zip ties on this right here to dress this up. Keep it all in one location. Take the strain off the wires. Right here. So then what we're going to do is we're going to move over into our breaker box and we're going to start wiring things together. So this is the bus bar I talked about, this big metal plate. And that would go in the top, but you can see if we're only using it on two, it'd be way over close to the edge. And we could take it in the shop and we could cut it. But for only two breakers, this works just fine. So that's pretty much it on the wiring. What we have to do now is we have to figure out how to actually program this charge controller. It's the first time we've ever used a Victron charge controller. So we're gonna have to try to download their app and figure out how to connect to the Bluetooth and see if we can figure out how to make this work. So we'll be right back once we figure that out. Alright, this might be a little hard to see, but we've got the Bluetooth connected after a couple firmware updates. And now we're going to turn the PV on and it should wake up and start charging. There we go, 10, 14, 15 watts. So there, now what we're going to do is we're going to put the cover on the box up here. We have all the breakers on. So we're going to put this cover on. And then we're going to see if we can make the load circuit work and turn on the lights. So now we're going to program, or attempt to program the load circuit. So now we're going to come back to the app. It has to reconnect. We're going to click on the gear. We're going to go to load output, and it's in battery life. Let's go always on. Now the light should be on the inside. I think we have to pull the pull chain on each one of them. Alright, so we're inside now. You'll notice that one's on. We'll pull the pull chain. Now normally I wouldn't have purchased pull chain porcelain sockets, but that's all they had at the hardware store, so that's what we got. So now the inside lights are on. So now let's go put some bulbs in the outside. Alright, so we're going to screw the bulbs in the outside and see if they work. I can already tell they do. That one's on. Alright. I don't really know how much power these draw. They're pretty... Alright, so we've installed all of our light bulbs, and as you saw, they were blinking, and that actually distracted me. That's what distracted me in the last video. Don't really know why. We know the system is sound, we know everything's okay, the voltage is correct, the polarity is correct. We're assuming it's because they were like 40 bucks on Amazon, and they're a very low quality bulb. So we have tried some other 12 volt bulbs, they work just fine. So we're going to have to find another source of 12 volt Edison style LEDs for ambiance lighting for the chicken coop. But other than that, the system is done, wrapped up. Just a quick recap. It's a 175 watt solar module. It's a 87 amp hour 12 volt AGM battery, and we have a 15 amp Victron charge controller. We went with the Victron because it has Bluetooth, and it allows us to be setting out around our campfire at night and turn on these lights if we want, or adjust things for seasons without going in the coop and tearing things apart. So the Bluetooth is really nice. We can open up our cell phone, and as the seasons change, we can extend the lighting for the chickens, because they need a certain amount of light per day, and without that certain amount of light, they don't lay eggs well. But you don't want to give them too much light, so you have to keep giving them a little more light as we go into the winter and taking it away as we go, into the spring. So, hope you enjoyed that. Any questions, leave them down below in the comments, and we'll try to answer them the best we can.